starting with math. Great way to start your day. So here we go. Now, let's just back up a quick second and remind ourselves, what is this? Yeah, but that's one of our BFFs. That is the squaring function. That's a parabola. And when we draw a parabola, this point right here is called the vertex. And for the regular old BFF, it's at the origin. Now, when we look at the first problem here, letter A, we see we have a squaring. So this is a version of the squaring function. So it is going to be a parabola. But we've stuck some numbers into the problem. We're supposed to know now what all those numbers do. So remember, if you have an add or subtract inside the parentheses, what does that do?
Moves it the opposite.
Moves it the opposite way, sideways, right?
Yeah.
So if it's -3, it's actually going to go right 3. And then if there's a +4 on the end, it's going to lift it up 4. So the parabola that was sitting here is now going to be sitting here, right?
Yeah.
So the vertex, which used to be at the origin, is now at 3, 4. This equation, if you look at it and remember all the stuff you know, you can look at the equation and say, oh, the vertex is at 3, 4. Thank you, right 3 and up 4. Now, what does that 2 do? It doesn't change the vertex, but what does that 2 do? I'm going to get this out, but you can put that away. What's that 2 do? Multiplies the height. So if we were actually doing this on graph paper, and I do not expect you to even reflect this at all on this, but that's actually going to make your parabola a little skinnier because it's going to be stretched vertically. But I don't want you to worry about that. For purposes of this exercise, we only care that the vertex is at 3, 4. Now, if I folded this parabola in half, the crease would be, the crease would be called the axis of symmetry, okay? This line right here is called the axis of symmetry or the line of symmetry. Sometimes it's called the line of symmetry. It's simply the line that folds the parabola in half. What is the equation of that line? Can you tell me? Yes, you can. Think about it. What is the equation of that line?
X equals 3.
X equals 3. Very, very good. The axis of symmetry is always going to be X equals, for a parabola opening up or down, it's always going to be X equals, and it's going to be whatever the X is in the vertex. Okay. Now, I kind of already, now which way does this parabola open? DO stands for direction of opening. Which way does this thing open? Up. Don't they all open up? Well, we could turn it upside down, right?
Yeah.
But what would have to be in the equation if it were going to be turned upside down? You'd have to have a negative out here, and that would turn it upside down. As long as you don't have a negative out here in front, your parabola is going to be opening up, because that's the way they open. So, our vertex for the first one is 3, 4. The axis of symmetry is X equals 3, and it opens up. Got it?
Can't they open sideways?
They can open sideways, but not if they are X squares.
Okay.
If they open sideways, they are Y squared. And I put my paper down somewhere. Okay. All right, so now let's look at the next one. And you're going to tell me you don't have to graph it, that's not necessary, but you need to be able to tell me the vertex, the axis of symmetry, and the direction of opening. Well, the direction of opening is easy. Which way is it open? Up. Remember, they're always going to open up unless there's a negative here.
Yeah, oh, no,
I'm on problem B.
D.
Okay. Now, where's my vertex? Well, think about it. How did this parabola move? It
Negative
started
1, 0.
here, but he came over one this way?
Yes.
So now our parabola opens from -1, 0.
Oh, yeah.
Now, how do we know it's still at 0? There's no number here, right?
No.
So it didn't go up or down, it just stayed put. What's the axis of symmetry?
X equals
Be
-1.
careful. Make sure you write an equation, x equals -1. It will always be the x coordinate, but make sure you write it as an equation. All right, how about this one? -2x squared plus 4. Vertex, axis of symmetry, direction of opening. Which way is it open?
Down.
Down. What's its vertex? Now look at it
0, 4.
carefully. Very good, Jalen. 0, 4. This does not go sideways, because the only way it can go sideways is if you have a number inside the parentheses with the x. If there's no number being squared along with the x inside, then you're not going sideways. But you are going up 4. So your vertex is 0, 4. What is your axis of symmetry then?
X equals 0.
X equals 0. Remember, your axis of symmetry is always x equals the x coordinate of your vertex. All right, we'll do one more. Let's see about D. What about D? Where is my vertex? What'd you say?
1, -2.
You are exactly right, Emma, because this goes right 1 and down 2. So if it helps you to graph that, go ahead and graph it. You don't have to, but we're going right 1 and down 2. So my vertex would be 1, -2, just like Emma said. What does that make my axis of symmetry? X equals 1, and it opens down. Okay, would you go ahead and fill in the bottom two, or E and F? Would you go ahead and do E and F? See what progress you can make with those on your own? And we will compare answers. This one right here.
0 is the vertex, 0 is 0.
That is just our regular BFF, right? So the vertex is just at the origin, which makes the axis of symmetry x equals 0, and the direction of opening is up. That's just your basic function. Everybody okay?
Yep.
Now, what about this guy now? He's been moved, so where's his vertex? 2, 1. We go right 2 and up 1, making the axis of symmetry then x equals
1 or 2.
X equals 2. It's always, remember, your axis of symmetry is always x equals the x coordinate of the vertex. Marita, you doing okay today? Just get up. And the direction of opening for this guy is up. Now, that is pretty easy. You have to admit, that is pretty easy. Unfortunately, most of the time, our equations don't come to us written in this beautiful vertex form. This is called the vertex form because you can look at it and see the vertex. Normally, your equations are written in what's called standard form, and that is this. Now, you need to come up with exactly the same information. You need the vertex, the axis of symmetry, and the direction of opening, but now your equation looks like this. Okay? Now, it was easy when the equation looked like this, right? So we're going to make this equation look like that. And the good news is you already know how to do it because we've even already talked about the process of completing the square. So that's what we're going to do. We're going to complete the square. So the first thing I want you to do is move this number to the other side. So move the 2, whatever the extra number is there, move him to the other side.
Can we flip like the thing around, like put the X and all that? Like, can we put the Y on?
Oh, totally you can. Totally. It's called the symmetric property of equality, and you are absolutely allowed to do that if that's easier for you. Now I'm going to add a number to both sides. Does anybody remember, and I got to do it on both sides, does anybody remember how we figure out the number that we add to both sides? Emma?
-2 divided by 2, and then you get -1 and then
Square root, or square it. Square it, yep.
it.
So we take half of this number, right? And actually, since you're squaring, you don't even need to worry about the negative. You can just take half of 2, and half of 2 is 1, and 1 squared is 1. So we're going to take half of this number and square it. So in this case, it's 1. We're adding 1 to both sides. Again, we take half of this number and square it. This side, the side with the X, will be a perfect square. And remember, you can get that a couple different ways. One way is you just factor this. This is X minus 1, X minus 1. Or you remember, this is always going to be X. This is always going to be that sign. And this is always going to be the square root of that. Always. So this is going to be X minus 1 squared. And over here, we have Y minus 1 when we combine like terms. Now there's one more step. What do you think we're going to do now to make that look like that? Add the 1 back over. Now you should be able to look at your equation and say, okay, the vertex has gone right 1 and up 1. So the vertex is at 1, 1. What's my axis of symmetry? X equals 1. And what's my direction of opening? Up. Remember, as long as there's a positive out here, as long as there's no negative sign out here, there's no negative anywhere here in front of the X squared. Oh, this should be 0. I don't know why I said 0. It's 1. It's X equals 1. You're right, Matthew. That's what he said. I wrote the wrong thing. So, what was I saying? As long as there's no negative out here, it's going to be always opening up. Always opening up. That wasn't too bad. Let's try the next one. What do you mean?
Take 2 out.
You need to get rid of that 2. You need to get rid of that 2. And there are a couple of ways that you can handle it. I prefer to divide everything by 2. Now at first you're going to be a little scared. You're going to look over here and say, oh, but don't worry. I promise it'll all come out nicely. It'll be beautiful in just a minute. But no matter whether you do it this way or if you just plain factor it out, you have to get rid of that 2. Now we also have to move this over to this side. because the whole key is I gotta add a new number here. What's that number going to be that I'm gonna add?
4.
4. Why am I adding 4? Let's
Take half
go
of 4
through
and
those
square it.
steps. Pay attention. We take half of this number. What's half of 4? 2. And then we square it. So we get 4. That's how we got the 4. Half of 4 squared. Now, this will be a perfect square. It will be x minus what?
2.
2. This, let's see, I gotta add that. So now what do you think we might do? Add over the 1, very good. We're gonna add over the 1, we gotta put it back. And then, remember this, we don't like that, but we can easily get rid of that by timesing by 2. But kids, when you times by 2, this is the part I want you to be careful of. When you times by 2, you multiply the parentheses by 2 and the number by 2. Don't do anything inside. You just multiply the parentheses by 2 and the last number by 2. So we move the 1 back over, we added the 1 to both sides, and then we times by 2. But when we times by 2, we just put a 2 in front of the parentheses and times that number by 2. So now you can tell me that my vertex is where?
2, 2.
Oh, let's see, right? 2 up 2, yep, 2, 2. Making the axis of symmetry, x equals 2. And of course the direction of opening is up. Now you're thinking, that's a lot of work, Mrs. Ford. Yeah, it is. Oh my goodness, look at the next one. What in the world? Oh my goodness.
Times all by 3.
Oh, what a great idea, Emma. Times it all by 3. Now, when I do that, I got to multiply both sides by 3. So this becomes 3y equals x squared plus 4x minus 20.
And then you have to
Add over the 20. Now I'm ready to complete the square, right? Ava, you remember how to do that?
Divide by 2 and square it.
Exactly. So what am I dividing by 2 and squaring?
4.
4. Half of this, so divided by 2, that's 2. Squared is 4. So I'm going to add 4 to both sides again. This is a perfect square. All this right here is a perfect square. What perfect square is that?
X plus 2.
X plus 2. And over here I have 3y plus 24.
Yeah.
Now start putting stuff back. So we'll move the 24. And then one more step. Got to divide by. Now, when we divide by 3, what is this side over here actually look like? Y equals, how do you think we might write this so it looks more normal? That's really nothing
Multiply
normal.
by a third.
Yeah, so instead of putting it over 3, make it 1/3 x plus 2 squared. Isn't that the same thing?
Do we have to write it like that?
Uh-huh. Yeah, this is not normal. This is not good. We don't like to see this. So we're gonna put that, make that 1/3 x plus 2 squared, and then of course we'll have our minus.
Wait, would you get rid of the plus 4?
What?
At the end of the problem. Why'd you get rid of it?
I didn't get rid of it. This factors
Oh.
into x plus 2, x plus 2. So I wrote it as x plus 2 squared. So what have I got over there? Minus 8. So now, what's my vertex? -2, -8. Very good. Remember, this means back up 2, down 8. What's my axis of symmetry?
X equals -2.
X equals -2, and my direction of opening is,
Down.
whoa. I think it's up. Isn't that a positive 1/3?
Yeah, just wrong. Sorry.
All right, one more of those. Here we go. Let's see if we got it. One more. Actually, I think I'll multiply everything by -2. So -2y is x squared plus 6x plus 5. Does that look okay to everybody? Timesing everything by -2. Okay, Stephanie, what happens next? You do. You absolutely do. Because we're going to get ready to complete the square, so we got to make room for this new number we're going to add on both sides. Different number this time. What am I going to add to both sides?
9.
A 9? And I'm adding 9 because half of 6 is 3 and 3 squared is 9. See what this cut? So I'm going to add 9 to both sides. Now this gets factored into a perfect square. So these 3 terms get condensed into a perfect square. What is the perfect square for x squared plus 6x plus 9? X plus 3. X plus 3. And over here I had -2y plus 4.
Yep.
Now we start moving stuff back. So we'll take the 4 back over. And then we'll divide by -2. But we're going to take a clue from the last problem we did. And what will we write here? Instead of putting this over -2, -1/2 x plus 3 squared plus 2. We divided by -2, right? So that's going to become a plus 2. Okay? Vertex, axis of symmetry, direction of opening. Here we go. What's our vertex? -3, 2. Remember, this means left 3, up 2. What's my axis of symmetry? And watch it now. Which way do we open? That one's a down. And you could tell that from the very beginning if you wanted to. Negative opens down. Okay, we've got 2 more things to do today, so try to contain your enthusiasm. Let's look at part 5. This is the first one, part 5. It's the backwards. So what you're going to do now is build your own equation. So you're going to come up with an equation that looks like this from the information that they give you. All right, now, we know that our equation is going to ultimately look like some number out here in front. In this case, it was a -1/2, and here it was a 1/3. Some number out in front, x minus something squared plus something, right? Isn't that what our equation looks like? Now, the good news is these somethings are directly related to the vertex, right? So if we know that the vertex is at -2, -3, that means we're shifting 2 units left and 3 units down.
Yes.
So let's see, 2 units left would be x plus 2. And then 3 units down would be -3.
Yes.
Does that make sense to you? Just working backwards? Now, anybody have an idea what we might do now? Plug in this x and y, because if I plug in 2 for the y and 1 for the x, will I be able to figure out what my n is? Yep. So let's see, here we go. One step at a time. What's 1 plus 2
3,
squared?
9.
So you have 2 equal to 9n minus 3. And you need to solve that. So what would we do to solve that?
Add 3.
Add 3. So 5 equals 9n. And n equals 5/9. So go back to your original equation. And n is 5/9. So our answer is y equals 5/9 x plus 2 squared minus 3. So we got a couple more to do here, but let's review those steps. Our steps were, the first thing we do is plug in the values for the vertex. We know what to put here and here because of the vertex. Then take the other point they give you and plug that in for x and y, and then do all the arithmetic to get your n value, and then you'll be done. So here we go. I know that my equation is going to look like this one. My job is to figure out what goes here, here, and here. I'm on problem B. The happy news is that I know my vertex. So what does that tell me in terms of the equation here? If the vertex is 0, 1. This is a 0, and this is a 1. Now, if you don't want to write x minus 0 squared, it's okay if you just write x squared. That's okay. It's the same thing. But if you want to leave the 0 in, that's fine too. Now what? We're almost done. What do we have to do now? Plug in. They gave me this other point, which was 7, 3. So 3 goes in for Y, and 7 goes in for X. So I have 3 equal to 49n plus 1. 7 squared, 49n plus 1. How do I solve that? Subtract 1.
Yep.
So 2 equals 49n, and n equals 2 49s. And then don't get so excited that you forget to write your final answer. Your final answer is y equals 2 49s, either x minus 0 squared plus 1, or 2 49s x squared plus 1. You can write it either way. All right, one more. Here we go. Our vertex is at 2, -1, and we contain 4, -5. Start with the basic format that you know. Okay, what can we plug in? What will I plug in these 2 blanks right here? So x minus 2 minus 1. Is that right? We're going right 2 and down 1. Okay. How do I figure that out? How do I figure this out?
Plug it in.
Plug in that point right there. So -5 equals n times 4 minus 2 squared minus 1. So first of all, you fill in your vertex, and then you fill in your extra x and y. And now we're going to work this out carefully. 4 minus 2 is 2, squared is 4. Not subtract the 1. This is 4n minus 1. You can't combine those. What you'll do instead is add it over and divide by 4. And then we write our final answer. Y equals -1 x minus 2 squared minus 1.
Is it okay if you just put a negative sign?
Yep. You just want to put a negative instead of a -1, that would be fine too.
That's true.
Okay? Alright, well, a couple minutes ago, so we have 2 more things to do. So we're done with 1. The other one is get that handout out that I gave you earlier. And the front side of it, the side that says Worksheet Parab 2.1, the front side of it, we've already done this. So pick one that looks hard, and let's go through that just for a little bit of review practice here. F looks hard. All right, let's do F. Oh, by the way, this is part of your homework, so you might want to just go ahead and work along with me here. I'm doing F. So here we go. Who remembers the steps to this?
Divide everything by 2.
Divide everything by 2. So x squared squared minus 6x plus 10. So I started by dividing everything by 2. Now what? Subtract 10. This thing, what happens next?
You divide 6 by 2 and then square.
Exactly. She says, I'm going to complete the square now. So I'm going to add something to both sides. And the number that I'm going to add to both sides is half of this squared. So half of 6 is 3 squared is 9. So I'll add 9 to both sides. So this is a perfect square. What perfect square is this, Miss Huff? X minus 3 squared, that's exactly right. So then over here, I've got y over 2 minus 1. So I add 1. And then to get final, I will times by 2. And when I times by 2, I times the parentheses by 2 and the number by 2. Don't change the parentheses themselves. You times the parentheses by 2 and you times the number by 2. Vertex. 3, 2. Right 3 up 2. Very, very good. Axis of symmetry. X equals 3. Direction of opening. Up. Got it. We have time. In a minute, we'll come back and we'll do a few more of those done for you. But now we got to look at the back, because the back is the other new thing for today. I think this is going to look familiar to you, because I think you did this last year, but I could be wrong. There actually is a formula for the axis of symmetry. X equals negative b over 2a. Does that sound familiar to you? Negative b over 2a. Now what that means is we can take an equation like we have here in problem A. And just like with the quadratic formula, that's your A, that's your B, that's your C. And we can say the axis of symmetry is x equals negative b, which would be 6, over 2a, which is 6. So x equals 1. You can get your axis of symmetry just right off the bat by doing negative b over 2a. Now, we still need our vertex though. Well, the good news is, what do we know about the axis of symmetry and the x-coordinate of the vertex? Aren't they the same? So if the axis of symmetry is 1, I know my x-coordinate and my vertex has to be 1. Okay, now I'm doing a different problem here. I don't know if it's negative 2 or not, but it might be. This is our problem. How would I find the y-coordinate, Tanner? Plug it in. Plug it in. Kids, since the beginning of time, when you've needed y, you have plugged in x. So if I plug in 1, I will get 3 minus 6 plus 1. I'm putting in 1. And so whoever said negative 2, you are right on.
Wait,
Wait, wouldn't you
Love
square
the
it?
square.
What's 1 squared?
Oh.
Yeah, you square it, but 1 squared is...
I thought you squared the whole thing.
No! What has the exponent here?
So we could have been doing that the whole time?
Yes.
Why didn't, that's evil.
Well, actually, Andy, there are reasons we need the vertex form. But yes, you can always find your axis of symmetry in vertex by just plugging in. What's our direction of opening? Let's remember PEMDAS, people. What does PEMDAS tell you to do first?
Parentheses.
And then exponent. So the first thing you do is square, and then you multiply. So first we square, then we multiply. So it'd be 1 squared times 3.
Got it.
All right. Let's pick another one from this page. Let's not be confused. Okay, so something like E, let's not be bothered by it. Let's not let it confuse us.
E is just 0, right?
We're doing E. This is E. So for E, remember, it's AX squared plus BX plus C. That's our lettering. So A is 1. What's the B for this problem?
0.
0. And then C, if we needed it, would be -10. But in this formula, we don't even need C. Do you see how your B term is missing? Okay, no issues. No issues. X equals -B over 2A.
0.
So we're going to have 0 over 2, which is 0. So our axis of symmetry is just 0, which means for our vertex, the x coordinate will be 0.
Just 0,
And I plug that in, and I get -10. And my direction of opening is up. Let's do one more from that back side. You see another one on there? We've done A and E. Is there another one you want to do? C? Oh, CS fractions, okay. So A is 1/2 and B is -4. So, Bo, what's my formula for the axis of symmetry? X equals
-B over 2A.
-B over 2A. So -B would be 4 over 2 times 1/2. Okay, wait a minute. What's 2 times 1/2? 2 times 1/2. Isn't that just 1? Kids, 2 over 1 times 1 over 2. Isn't that 1? So my axis of symmetry is 4 over 1, which is just 4. Which means that my vertex is 4, comma. Now how do I find the y coordinate change line? Plug it in. So I'm going to plug it in. So I have 1/2 times 4 squared minus 4 times 4 plus 1. PEMDAS. Square first. So that's 16 times 1/2. 8. 4 times 4. I heard somebody say -7 earlier, and you were exactly right. That's -7. So your vertex is 4, -7. And which way do we open? Up. You okay? All right. So, Monday starts a new quarter. We gotta have grades, so we're gonna have a little quiz on Monday. quiz is going to have 3 problems on it. Okay? 1 problem on the quiz. Is it a polynomial function? Why not? If not, why not? So the answer would be no, because x is under the radical, just like Brooke said. Now, let's review the other rules. Because one way you cannot be a polynomial is to have an x under a radical. What are the other things? Can't have a negative exponent. Can't have a negative exponent. Can't have what? Can't have x in the denominator of a fraction. And you can't have a fractional exponent. So go back and take a look at those 4 things that keep us from being polynomial functions. X under radical, x in denominator, fractional exponent, negative exponent. Okay? Next question on the quiz, or another question, I don't know where we go again. Write the linear function where f of 1 is 3 and f of 3 is 9. Oh my goodness. Anybody remember this from yesterday? What's happening here? Well, yes, but Olivia, first of all, we remember that this just represents ordered pairs, right? So this is 1, 3 and 3, 9. So when she said find the slope, she's recognizing these are points. So the slope would be 9 minus 3 over 3 minus 1, which is 6 over 2 or 3. And then what, Magnus?
You put that into y equals mx plus b.
You absolutely do. So you think about y equals mx plus b, and now we know our m is 3, and we pick one of our points. I'll just pick 1, 3. So 3 equals 3 times 1 plus b. Oh my goodness, what does b turn out to be? 0? So my equation is just y equals 3x plus 0, or just y equals 3x. And then the last question on the quiz, or the third question on the quiz, is going to be, I'm going to give you an equation, and you're going to find the vertex axis of symmetry and direction of opening however you want. However you want. So if the equation looks like this, and I said find the vertex axis of symmetry and direction of opening, are you going to use a formula? No. If it looks like this, you're going to say, oh my gosh, the vertex is at -2, -3, which means the axis of symmetry is x equals -2, and the direction of opening is up. But if the equation looks like this, you don't have to. You can do it any way you want. So you could put it in vertex form, or what else could you do? Andy, what else could you do if we need the vertex axis of symmetry and direction of opening? I have a formula. Could I use my formula? I could say x equals -b over 2a. And then, yeah, whatever. In between the lines, we can plug it in. So if the x is 2, so my axis of symmetry would be x equals 2. My vertex would be 2 comma, alright, so this is negative 2 squared. I'm almost done, hang on. Negative 4 plus 8 minus 2 is what? 2? And it opens. Oh my gosh, no! How does it open?
No.
You guys. Okay, so what happens on Monday? We have a quiz.